The greatest threat to businesses today isn't the outsider trying to get in. It's the people you trust, the ones who already have the keys, your employees, contractors, and privileged users. 60% of online attacks are carried out by insiders. To stop these insider threats, you need to see what users are doing before an incident occurs. Observe It enables security teams to detect risky user activity, investigate incidents in minutes, and effectively respond. Get your free trial at observeit.com/securityweekly. Signal Sciences secures the most important web applications, APIs, and microservices of the world's leading companies. Protecting over 7,500 applications and 150 billion production requests per week, Signal Sciences Next-Gen WAF and RASP help companies increase security and maintain site reliability without sacrificing velocity, all at the lowest total cost of ownership. Signal Sciences' patented technology protects any application against any attack, with integrations into any DevOps toolchain. Signal Sciences, demand more from your WAF. Learn more at signalsciences.com/PSW. Security teams need network data to threat hunt and resolve incidents, but find that PCAP is often too much data and NetFlow isn't enough. Corelight was founded by the creators of Zeek, formerly Bro, and its sensors provide just the right amount of data, transforming raw traffic into comprehensive logs, extracted files, and custom insights so analysts can make fast sense of traffic and move at the speed of attack. To find out why Corelight is your best next move in security, visit securityweekly.com/Corelight.
Welcome to Security Weekly. I am your host, Matt Alderman. We are recording live from Black Hat 2019. We're in our suite in Mandalay Bay, and joining me for this interview is Mike Weber, Vice President of Coalfire Labs. Welcome.
Thanks, Matt.
So here's two Colorado guys, right? We live kind of at opposite ends of Denver on the other sides, but we get together in Las Vegas to have a conversation.
Sure, I see a lot of people here in Vegas every year that I don't see even around the neighborhood.
Yeah, exactly, right. So we're going to cover some interesting research that your team is doing recently and get into some of the details. I think we're going to start with industrial or IoT. I sometimes say industrial IoT/IoT, depending on which angle of the Internet of Things we want to review. So what's some of the research you've been doing in the IoT space lately?
So what we've been doing in IoT is some research into practical applications of being able to exploit these systems to cause some physical damage in certain cases. Right now we're working on a project. It's proof of concept to exploit basically 3D printers. So cloud-enabled service 3D printing systems to be able to cause, our objective is to cause fire.
Oh, okay.
We're trying to light 3D printers on fire through remotely exploitable channels.
Yeah, Art Coviello in RSA, I think it was like 2013, somewhere in there, in his keynote at RSA said, look, we're getting to the point now where we can have a destructive attack, right? That we have this proliferation of devices, and the way attackers are going is that we could actually destroy something. And what your team sounds like they're trying to do is to see how real it is to actually create a fire or cause some damage.
Right. I mean, we've been talking about that for years. There was work up at Idaho National Labs many years ago, over a dozen years ago, against power generators, flipping them on and off until they self-destructed, which was done over the network just by exploiting the openness of the protocols that are used to communicate with them. So in that same vein, we're attempting to have a proof of concept to be able to reverse engineer a common 3D printer that is cloud-enabled and remotely be able to rewrite the firmware, update it, and then cause it to melt itself down.
Interesting.
So yeah, it's
scary.
Yeah, it's a fun proof of concept, and that's one of the things that our R&D team does is get into the new cutting-edge technologies and try to do some fun stuff. It's really to be able to promote awareness of the security risks in some of these solutions.
Mm-hmm. Now, are there other areas in IoT that you're also looking at? Industrial control systems, corporate networks outside of 3D printers. What else is out there?
Sure. So we get a lot of work from clients looking for us to test non-traditional IT solutions. So devices, hardware testing, and every piece of hardware now is internet connected. So there aren't a lot of things that aren't within the Internet of Things.
Right.
So while we're doing a lot of work in that space, we're also doing some work in industrial control systems and the SCADA space. Now, we're not doing too much on the R&D side because it's not exactly the easiest thing to do to be able to set up a functional lab environment. that we wouldn't mind destroying, of course.
Right.
But that is also it's on our horizon to be able to do some of that work.
Yeah, that's a scary area for me because so much of our critical infrastructure in the United States and in anywhere around the world has a lot of these SCADA industrial control systems in them. A lot of people don't understand those systems, I think, in how they work and communicate, and a little scary if they get connected to the internet and what could happen potentially to those devices. We're also going to talk command and control channels a little bit. So what's some of the research you're doing there on C2?
So there's a proliferation of applications that promote collaboration and communication, right? I mean, they're all over. They're used. It's the effect of the bring your own device days, where the user community in an organization ends up driving some of the collaborative applications that are used within an organization.
Right.
So what we found is that organizations are facilitating this because there's a lot of benefits to be gained. People are more productive, work gets done more efficiently. That organizations are allowing these third-party or external apps to be used as collaboration and communication platforms, which means that it is free reign to be coming in and out of an organization.
Right.
So we have just recently released a tool called Slacker. We built it on the very robust Slack API.
Yeah.
And it leverages Slack to be used as a CNC channel for compromised systems within an organization. So in a red team context, we would use that to be able to exfiltrate information out of the organization and to be able to control the systems and move laterally within the organization for the systems that are compromised.
Got it.
Again, it was a bit of a proof of concept,
right?
Just to bring awareness to the fact that a lot of these uncontrolled applications and communication channels are presenting a risk to organizations.
Yeah, and we've seen lots of software that gets installed on machines that have phone home capabilities. And embedded in some of that phone home capability is this covert channel that is actually being used for command and control across. And so it sounds like you looked at Slack, obviously, which is one of the big ones. But any other types of those? Because we've covered on the different shows some of these other kind of phone home technologies that also could be these covert channels.
Sure. Well, the impetus for Slacker was there was a open source tool called Twitter. So it used Twitter for the same purpose.
Right.
We just built one using Slack. It's a little more robust and there had more functionality.
Yeah, interesting.
Yeah.
Also, you said you were doing some cloud research, probably a little more associated to IoT and edge, but curious, kind of what research you're doing over there on the cloud side.
So we are. So the cloud components are part of all the research work that we do pretty much because everything is using the cloud. Every organization's using the cloud. There's a huge migration to the cloud. There are cloud providers of every type. That are looking for security services as well.
Yeah.
So we do a lot of work in this space. With this and with IoT as the tie-in here, the IoT systems, IoT is not IoT without the cloud.
Being able to communicate and do something somewhere, right?
Right,
yeah.
And using the channels and specific features of cloud providers' IoT services, we're able, those are things that facilitate the deployment of these devices, the rapid development and deployment into the field, and the operations. So the cloud functions in the IoT space are really where the backbone is. Now, doing R&D on systems that you can purchase and have in your lab, which presumably gives you the right to be able to test it in however way you would want to. We can't test the back end systems.
Right.
So a lot of the work that we're doing from that perspective is man in the middle and being in between the system and the cloud as the proof of concept. On the flip side of that, we work out theoretical ways to be able to do this across a cloud provider. Now, testing a cloud provider without their permission, you could clearly see that would be a bit of a problem.
Just a little bit. I'm sure AWS and Microsoft don't appreciate that.
They don't look kindly on that.
Yeah.
No. But we find that that's a key part of the infrastructure that I think is a little bit light on testing from the security community because of the nature of violating terms and conditions and getting
infrastructure may be a little easier, but platform as a service definitely true software as a service
Right.
would be really, really difficult.
Right. And yeah, we do a lot of work in the software as a service space as well for many of the large cloud providers
Got
and
it.
Organizations that are moving to the cloud. I don't think there is software that isn't software as a service anymore. It's really challenging to find those instances.
Everything as a service.
Right.
Or in the case of development, everything is code.
Right.
Seen anything with edge computing? Because one of the interesting use cases with IoT, industrial IoT, is kind of these edge computing environments that are kind of the middle ground to full back-end cloud, right? Have you done any research there? I'm just curious, kind of what you're seeing with the edge providers and edge technologies.
Yeah, we haven't really done anything in that space. It is very. I think it's got a lot of potential though.
Yeah, and we saw the last company I worked for on the container security side. We were seeing a lot of new edge computing devices coming in for these IoT sensors to talk to as kind of an intermediary broker. You might have multiples of them then communicating back to a cloud service. So we're going to add another layer in this research at some point for you guys.
Right.
I'm just curious if you've done anything.
Right.
There.
Well, when we're testing testing solutions under contract, of course.
Right.
Then that's where we're seeing a lot of that. And it's really interesting to see how different providers are building their solutions based on different cloud models. Some go all in. Some solution manufacturers will go all in on one platform, one vendor, one cloud vendor. Whereas some will go for a hybrid model or build things that are extensible, where you can swap in and out based on whatever organization they're building a solution for prefers.
Yeah.
I think that's telling, really. On another topic, I'll just keep changing topics.
Yeah.
On another topic, we do a research report every year that covers aggregated findings for what we've seen in the previous year. And we've got the new version of that coming out here, hoping to have that out by September. It covers a year of the penetration testing work that we've done. And what we found is in prior years that we've done, that we've looked at, there are plenty of traditional enterprise vulnerabilities.
Right.
Because the cloud providers are looking to go to market, so they're looking to employ our services for the testing. For organizations that are building solutions now, they're being built in the cloud. So we are testing on cloud providers much more in the last year than we ever have before. So just as the industry is going, well, so is our practice. Our practice is focusing more on the cloud because that's where all of the demand is. And we're seeing a different type of vulnerability across these things too. Primarily, they go from technical vulnerabilities that can be exploited or whatever to configuration issues.
Yeah, some misconfiguration.
Yeah, when there's multiple configurations that you can leverage to be able to compromise a solution. Similar to what recently happened with the Capital One incident.
Well, and as we've seen lots of S3 bucket misconfigurations, allowing data to be exfiltrated. So, Paul and I have talked a lot about this in various shows. Is the new vulnerability is the misconfiguration in the cloud. It's not I've got a remote code execution vulnerability. I have the vulnerability because something is misconfigured and it's allowing somebody to get in that shouldn't be able to get in.
Too many permissions on a service account or things like that, which are, we find that in practice all the time. It's reflected in a report that's coming out. It's really interesting to see that the work that we do actually reflects what the trends
what you're
are.
Seeing. Yeah, that's interesting. Anything else you want to cover? Did we hit it all?
I think we did. We spoke about R&D. Obviously, we're here at Black Hat. We have our booth down on the vendor floor. It's been a great show. Caught the keynote by Dino. I could butcher his last name if I get it, but his keynote that talked about every security company is now a software security company, or every security organization, software security organization. Same thing with everything moving to the cloud and how that is changing the face of technology.
I've seen Dino's keynote in Asia like 2 years ago, and it was fantastic. The pace of change with applications is going to change the way we have to think about security, and a big believer of that for sure.
Absolutely.
If people want to get more information about Coalfire or to get your report when it comes out, where should they go?
Oh, sure. It's all available on coalfire.com. We have a section on our website. Nothing real special about it, except it covers all of our labs, functions, and services, as well as our R&D team. Links to all the things that we've deployed as open source on our GitHub page.
Awesome.
And so everything's up there, including all the tools that we've talked about here.
Great. Thanks, Mike, for joining us.
Thanks, Matt.
And thank you for watching. We'll see you next time.
Welcome, everyone, to our Black Hat 2019 series of interviews. Of course, I'm very excited, as always, for all of our interviews, and we're going to be talking about all kinds of packet analysis and AI and machine learning, which is more than just a buzzword, and we'll get into it. Here to help me with that is Soumitra Das. He's the CTO and co-founder of BlueHexagon. Soumitra, welcome.
Thank you. Welcome. Good afternoon.
Yes, nice to have you. So I guess first start with those that aren't familiar with BlueHexagon, what problem are you trying to solve?
So the problem we're trying to solve is detecting both known and unknown threats in real time. And we live and die by the motto that we need to detect things in a second. Anything after that is too late, it's moved around, you have to hunt for it. So whatever we do, we need to make sure we can do that in 1 second and give a real verdict. So that's how we...
So you're not storing a whole bunch of stuff and then analyzing it later, right? As it comes in,
exactly.
You're analyzing it. And
we're not hunting for it,
Okay. And how are you getting the packets or traffic? Is it a span port?
Yeah, it's span or tap port. And typically it's next to a packet broker, a firewall, a switch, or a decryption device, whatever the customer has. But anywhere we can get a sense of the traffic, that's where we sit.
Okay, and full packet capture,
Full
not
packet
just
capture.
NetFlow, right?
Not
You want
exactly.
full packet capture. Agreed. The network doesn't lie, so I like your approach already. Right. But now you can also do this in Amazon AWS as well?
Exactly. We just announced that recently. We've been working with them on that feature for almost a year and how to architect it well, because in the cloud, traffic scales up and down very quickly. It can go from 1 gig to 40 gig.
Yes.
And your inspection has to scale the same way. So we get a copy of the traffic, but what's interesting there is you can bring it up, with a script, with a Terraform or a CloudFormation, and it just scales up and down as the traffic goes up and down. So it's very easy to
your
deploy.
analysis is also done in the cloud
Exactly.
for that to have that
Exactly.
scalability.
Exactly.
I see.
Yeah.
That's
it's
awesome.
just as if the appliance is deployed right next to your network.
Yep.
It's still a network, whether it's there or here.
And
how
that's
we look at it.
anything within AWS, you can get that traffic.
Yep, exactly. Any instance. And the customer can decide if they want to choose specific instances to mirror the traffic from. So
That's awesome.
Yeah, instead of having a packet broker, they can just choose, I want these 5 instances or these 10 instances from these VPCs and just mirror them.
That's fantastic. That's really, not many are going to that level of granularity in AWS.
Exactly.
That's refreshing to hear.
Yeah,
as more of us deploy into the cloud, right?
Yeah, exactly.
Everyone's marching in that direction.
And what's very useful for our customers is that they have on-prem, they start there, and this makes it consistent, the journey to the cloud. They have the same dashboard, same visibility. It doesn't matter if you're on-prem or not. It's the same kind of detection. Before, what's happening is you have big iron on-prem. When you go to the cloud, you need to have these 10 different startups for every small thing. Now, the traffic makes it consistent. It's the common source of truth for everything we do.
Now, when I first started looking into packets and understanding packet headers and payloads in like 1999, I was like, this is awesome. And when we would have all kinds of discussions and classes about what to look for. Fast forward to today, you're looking at traffic in real time. Right. How do you decide what to look for and what to maybe flag as anonymous or malicious or not?
Very quick. Actually, I was at Carnegie Mellon and US CERT in around 99, 2000 time frame. And we used to play with PCAPs, and we used to make a model that will take 6 months to train and doesn't do anything really useful. Yeah. So we were trying we were playing with machine learning.
We all went down those same paths of writing scripts to analyze PCAPs, right?
Exactly. So so the issue was machine learning wasn't great back then.
Yeah.
And actually, the company we have now, even 3 years ago, we couldn't have done it. I've been at other big companies looking at deep learning for 10 years now. Before it was a marketing fad. Yeah. Before it used to really work. Right. Now you have Siri and you have self-driving cars, so it does really work. Yep. And it's been interesting to see how with more data, that's number one, and more compute power. So we use at least 30 to 40 GPUs, large machines in Amazon to train these models. All the data is an S3. It's terabytes and terabytes of data. So we couldn't, even when we started the company 2 years ago, it used to take us a few months to train a model. Now it's a few days. So it's
because you
very
can get
training,
more data at once to train the model.
Exactly. And the model can also, the difference between deep learning and machine learning is the human doesn't introduce his preconceived notions into what to look for. So imagine that you have a PCAP. We don't try to say, look for this flag or this SYN bit set. Because the user gave you some kind of input, right? Exactly. Yeah, you're doing it without user Exactly. We say this is bad. We just need to make sure the PCAP is bad. And then we let the machine deep learning decide what to look for to best understand that bad. And given millions of these things, it can find counterintuitive things that maybe human didn't think about. Hey, attackers are using these specific patterns, which maybe I didn't think about on my own, and I don't want to bias the machine into doing that. See, I love that approach because I feel like that users pollute the machine learning algorithms more so than they help them. Right? Very true. So that's why we've taken humans, the users, out of the feature engineering job and move them to the labeling job. So we still need humans in the loop, but the only thing they're doing is telling us what's good and bad. They're not teaching us how to, what to look at in the PCAP. So if you look at what happened in voice, we used to have, waveforms and translations of the waveforms, and then we used to decide, hey, look at this, look at the pitch and frequency. We used to try to bias the machine to look for those things and build rules around it.
Right, and that's exactly what you're introducing is bias,
Yeah,
right?
exactly. And what happened now with deep learning is, oh, let me just feed the time domain waveform of the speech, give it the translation in English words, and it's going to find out what in the waveform I need to look at to match the output.
And that's why a lot of systems will ask you, was my answer accurate? Like you hear all the series and the
they're retraining.
Yeah, they're retraining
Exactly.
essentially based on the user's input.
And we do that to, I know there's a lot of buzzwords in the industry. I have 0 false positives, 100% detection. Any statistical system will make mistakes.
There's a variance in
there's exactly,
right.
exactly, because it's probabilistic. That's why it works so well, that it can find the unknown. So you have to give it, leeway to make some mistakes. The question is, how much mistakes do you make and what's the nature of those mistakes? With deep learning, because of the capacity of the model, they're really large. They take in a lot of data. They can find non-convex functions. So if the good and bad are very close to each other, it can find a weird boundary between them. It's able to minimize those mistakes. So we want to choose algorithms that will minimize the mistakes you can make given the same amount of data.
Right.
And that's what deep learning is good at.
And so it's not like a robot that you see in the movies that's completely autonomous and thinking and having feelings on its own. I think that's when people think of AI and machine learning, that's what they think is happening.
I think that's AGI.
Right. Yes.
So that's advanced artificial general intelligence, where you not only classify, but then you reason about it and you then act on the reasoning.
Right.
And that, I think people in robotics are working in those areas.
Sure.
That's going to take a while too.
Oh.
And this is not that, for sure.
Agreed. I think
it's the first part of it.
We've seen data on Star Trek, right? And we all think that that's what's behind all our machine learning algorithms and security. But it's really just allowing the computers to make smarter decisions for us, right?
Exactly. And we've seen this in medical, the medical field as well. Computers are better at detecting glaucoma. They're better at finding tumors, just because they've seen many more examples.
Right.
And they've learned to generalize. They're not biased by the examples only a human may have seen.
Yes.
Exactly. And that's the key thing we're trying to bring to this picture, because we're looking at 10 years of threats. We won't just see the threats those analysts have looked at in that organization. It's looked at enough of them to understand how malintent is expressed in code and packets. That's really what we're doing.
And so it's not a distinct signature. It could be a set of different behaviors and indicators, right? That
millions of them.
So a computer can make a lot more decisions than a human can in that case, right?
Yeah, exactly. It can find the right boundary. Like it can find. So, for example, how do our eyes work? They look at lines and circles and they can tell it's a face because they've composed them together. Deep learning works very much like that. They'll take these raw features like API calls and code sections and entropy, and they'll figure out how they fit together and help describe what is good and bad. So they infer what things that are counterintuitive that the attacker ends up doing without actually meaning to do them, and it's finding those kinds of things that are expressed in the code.
I agree, and I think it's a fantastic point, because when I interview those on the attacker side, and they very closely emulate user and or program application behavior to achieve a slightly different goal, right? I may impersonate a user, do things they maybe normally do. At some point, the attacker is going to use whatever they have access to, the credentials, the application, to slightly step outside of the boundaries. As a human, I have a really tough time looking through all a pile of data to say, well, that user normally accesses that share, but yesterday they sent a whole bunch of data to that share. Or I mean, that's kind of a bad example, but there are even more subtle variances. But deep learning can find those variances much better, or at least give us a set of examples that a larger percent are actually an attacker.
And actually, that's a very good point. One of our customers tells us the industry is focusing too much on tools that generate more data. I already have a data of 10 years I can't go through. Now the tool generates more data for me to look at. I don't need that. I wanted to give an opinion. We want to be opinionated about what we see, and hold our feet to the fire, saying, okay, we said this is bad. Now either we made a mistake or we are right. We can't just say, hey, it's sort of bad, why don't you go and check it out, right? We don't want to do this lead gen for threat hunting. We want to make a real verdict, and that's what's missing in the industry. And going towards not robotics and advanced general intelligence, but at least saying we do detection and then we integrate with all our partners. We work with the big endpoint vendors, with firewalls, with NAC. So we try to make the existing controls better by informing them early. So
Right.
so you get to the next part of actually remediating as well.
Mm-hmm.
I mean, it's not like a robot is going and fixing things, but at least it's autonomous. It's automating the fixing of things by detecting early and detecting well.
Mm. What's a typical deployment like? Do people have those aha moments the instant they turn it on and they go, "Oh my God, what's that?" and people go running out of the room? Because it sounds like you would have that
Yeah.
experience in what
Yeah,
you
it's-
described.
Yeah, it's very interesting because we are not baselining. We don't say we're going to sit there for 3 weeks
Mm-hmm.
and then we'll come back and tell you interesting stuff. So we say, oh, we came in. Either there's something going on right now, we'll see it right away, or hey, let's take the 1,000 new things that came out today. All dark web, virus total, and all these different repositories. Let's just take new things that came out today morning and just download them into your enterprise and see what, if any, control will catch it,
Mm-hmm.
and just let us look at it as well. And so that gives a very nice picture.
Oh,
It's,
that's
it's, it's,
interesting,
it's not
yeah.
made up. Just get 1,000 things in 5 minutes and see what you get. Maybe something will block half of it, 20%, something may block 5%, and you get a good picture of how much is being missed. And so it's a very clear ROI for the customer.
That's
to look at that,
fantastic.
yeah.
Tell me a little bit about your integrations. Are you integrating with things that are automatically blocking and remediating as well?
Yep. So actually, recently, just today morning, we announced our integration with Microsoft ATP Defender,
Mm-hmm.
and it's very prevalent. It's in every Windows endpoint, for example, and and Mac as well now. And what's interesting there is there's multiple kinds of integrations. We are in the network. We see things early. We'll also see things that are never written to disk on the endpoint, like fileless attacks, but we'll see the code flying by on the network.
Right.
So any of those kinds of things, we can do things like, if you see this hash, don't let it run, or delete it from the endpoint, or even isolate the endpoint completely.
Yep.
You could even say, it's going to this IP, don't let anything go to this IP. And all of this, many of these can be done very quickly. Some integrations take longer, maybe minutes, but many can be done in a couple of seconds. So you really get end-to-end detect on an unknown sample coming through, detection and remediation in seconds, which is sort of unheard of at this moment.
Yeah, that's fantastic. If people want to learn more, how they get a trial or a demo or?
So we have we can send virtual machines or physical boxes. We have a very interesting cloud POV. We put up a proxy in the cloud connected to our appliance, and you just point your browser there and surf the web. We have a malware repository that's updated every single day. You can download and you can use your own samples. It gives you a way to try it out very quickly, and then if you like it, deploy it in your premises or in your cloud, wherever you are, and just see how it works out. And it's very clear. It's not like you need to sit for 3 weeks and see what happens. You can just try it right away the moment it comes in.
That's awesome. Yeah. Thank you very much.
Thank you.
Welcome, everyone, to our Black Hat 2019 series of interviews. In this interview, I have with me Chris Kennedy. He's the CISO and VP of Customer Success at AttackIQ. Chris, welcome.
Thanks.
No relation to Dave?
None.
Okay. Just checking. Chris, you want to talk about the Mitre attack framework. And I thought it was interesting is when we were talking just before to prep for this, is that you said like 3-4 years ago, like no one was really using Mitre attack. Like what were we doing?
Right.
It seems like there's a very sharp contrast, like pre-Mitre attack and post-Mitre attack.
It's exploded.
Yeah. Why do you think it's exploded like that?
Well, I think there's several reasons for that. First and foremost, security operators that are in the trench have found a way to communicate more effectively with Mitre attack in terms of decomposing what the nature of a threat is, mapping that back to the controls that would protect against that specific threat, and then being able to benchmark and measure is that control effective or not. And so by the decomposing of the kill chain and showing what control should protect you within the kill chain, you can then start doing mappings of understanding where you have significant gaps in your control posture.
Do you need some scotch? I think you need some scotch.
I do.
You have a kilt on, so we broke out the scotch. Cheers,
And
Chris. Thanks for coming on Security Weekly.
Thank you. And late night last night, so I've got a little bit of my voice.
This
remaining.
helps amazingly well. That's awesome. So we talk a lot about Mitre attack today, as if it has been around like forever, right? Like we were lost without it. But there's a continued investment in it. What I want us to think about, and your thoughts on, Chris, is how do we measure its effectiveness? So now we've got this great new matrix that a lot of people are using.
Yeah.
But if I didn't have Mitre attack at some point in time, and then I implemented it in some capacity, how do I measure the effectiveness? How did it increase my security posture? How did it increase my red team capabilities? How did it increase my communications with various teams? What are other measurements, and how can we measure the the effectiveness of Mitre attack?
Yeah, I'm on a crusade for this, being in the risk management community for a long time as well. What I think is really interesting about the question itself is, as you mentioned before, that we didn't have Mitre attack before. So how did we measure before? And the methodologies that we applied were highly subjective, very temporal. And
we weren't breached, therefore everything was working great.
Right. I did an audit 6 months ago. It must be working the way I thought it did. And so Mitre attack affords an interesting opportunity to study that, decompose what your control posture should be based on known attacker behaviors, and then figure out what controls you actually need. Now, what makes that neat in terms of the measurement capacity of that is that at the lowest level, Katie Nichols has a wonderful blog about this in terms of getting started with Mitre attack. Pick and choose the controls that you have within your environment and map that specifically to the framework. That's just an assessment of the controls you think you have against the tactics that are used against them.
And it sounds really difficult and tedious to do that. And it probably is,
somewhat.
but it's worth it.
Once you do it,
yes.
And once you get over the hump,
yep.
And then you fold it into your SDLC process and things like that, it becomes old hat. And so that's wonderful. So once you've done that, you have an immediate view of what tactics do I have absolutely no coverage for. Well, that's a big hole. And then you start thinking about what threats am I most worried about. You can instantly threat model. What threat I'm worried most about, no coverage, priority one activity. Let me go close that gap. And so that's a really wonderful way to measure what specific capabilities I need right away. But then through time, what you can do is with capabilities like AttackIQ and what we do is that if you enable some form of emulation testing to validate the control is working, you identify these gaps, you use the platform and the automation behind it to measure where you have gaps today and where you have gaps tomorrow and show work done in terms of closing gaps.
What I love about AttackIQ and the concept of breach simulation is, as I mentioned before, I'm doing a lot of development lately. I really love the concept of agile development.
Of course.
I think AttackIQ allows you to do that style of agile. In other words, I write the test first.
Yep.
I test my application, infrastructure, whatever it is, and then if it fails, then I go fix it.
Totally.
Now I have the test, and I can continually test to make sure that I never have that condition again.
Absolutely.
That could expose risk.
Absolutely. We find that many of our customers that have embraced more modern computing methods are folding in AttackIQ for the test harness functionality to be able to build the unit test as part of a continuous validation for the particular release and the security they want built into it, as opposed to the more traditional Mitre attack customer that has a traditional enterprise and is more worried about the traditional risks that are articulated there. So, I think AttackIQ and the breach and attack simulation concept and having continuous security validation as a cornerstone of your SDLC process is a is a killer app that needs to be embraced, and I'm excited to see that happening.
Agreed. Yeah, I think there's a lot of lessons from DevSecOps that can be applied to traditional infrastructure, and this being, I think, a great use case. And now to have a framework to start building some of those components on top of is great. So, I mean, that begs the question, what is Mitre attack good for? And what I really want to know, Chris, from your experience is how are the different sub-teams within an organization using Mitre attack? Because I'd gather that the red team is using it different from the blue team. I think the blue team is made up of your security division, your sysadmins, your network admins, maybe your help desk, audit and compliance, right? And even each of those subcomponents of blue team use it differently.
Yep. So it all depends on the orientational lens of what you want to achieve, right? So as a red teamer, you're taking the outside-in look of what it would be to be the adversary, and you can take advantage of Mitre attack as understanding what the common tactics that would be. So you take the threat lens.
It's like a map. It's not specifically the code that you'd use to do that, but it's like you should execute the attack this way.
Yeah.
You go find ways to, and it's a project plan for your red team, right?
Fundamentally, and I think at a different level, if you think about how the red team should approach how they actually conduct adversarial activity. It's one thing to be a really good red teamer and know something that no one else does. It's another to apply the risk bias of probabilities to that.
Yes.
And so, like, I'm going to emulate APT 29 because I have indicator of that activity in my environment, or them coming after us. Let me try to emulate what they would actually do before they do as a red teamer, determine if I've got adequate security to protect it. So that's kind of what I consider kind of the red team lens and how they would embrace Mitre attack. The blue team allows you to take whatever the control functionality responsibility is. If I'm the engineering team that runs specific sets of controls, I can map those controls to Mitre ATT&CK in terms of what tactics, and then benchmark and measure the effectiveness of those controls and assign that as a responsibility.
PowerShell is an example.
Yeah.
If I run a Windows network inside Mitre ATT&CK, right, it's telling me that I need to control how PowerShell
It's a really
is
important
run,
one.
right? And it is a very important one. But without that, I just hear people speaking at conferences going, PowerShell can be used for evil, and I dismiss it.
Right.
Now, as if it's part of that, now I can look at my infrastructure and go, wow, either I have zero controls, anyone can run PowerShell anywhere they like,
Yep.
right? Or I can start putting some controls around that. And it gives defenders that framework to say, either I have controls or I don't, and help not really help prioritize, but at least give you a list to prioritize as a team. Right?
That's correct. And I really like how the Mitre ATT&CK framework allows that story to be told.
Yeah.
Like once you do that assessment and you start doing that control mapping and you start doing those evaluations, you start realizing I've got some big picture things I've got to clean up within my enterprise. I have unconstrained PowerShell in my environment. This is a primary tactic that's used by these specific threat actors. Now I can tell the story to the board or whoever in terms of what my strategy needs to be.
I think it's a better conversation with management, too, because you can communicate where your gaps are.
Yeah.
And then work with management to help prioritize them and also understand, PowerShell as an example, how much work it is and the potential impacts, and then prioritize them, right? Maybe take care of some of the easier things first, right?
Yeah.
You can almost create a matrix off of it, like level of difficulty and risk to the organization, potential risk to the organization, likelihood of compromise.
Yep.
Create a matrix to help you prioritize all those projects. Because I guarantee you, most organizations out there today, from a defender perspective, are going to go, yeah, we're missing all these controls. But now you've got to prioritize them, and there's a lot of factors there.
Right? There is. There's in terms of tech strategy, where the organization wants to go, what threats are actually relevant to you. But at least you have a framework to then overlay those threat models to actually have those conversations. Because I tell you, being in the practitioner seat for 20 years, most of those conversations today are driven by fear, uncertainty, and doubt, egos, and who has the most powerful voice in the room.
Agreed.
And that doesn't solve security.
I think the other component that I really like, and I've seen that threat analysts that work for organizations are adopting the Mitre ATT&CK framework. So I think when you look at adopting it, you need to realize that is multiple organizations need to be adopting it all at once.
Yeah.
Now you have a shared framework that you can all use, not to what you're going to attack, what you're going to defend, but then what threats are you going to look at and how that ties back. And if it's all using the same Mitre ATT&CK framework, you're in great shape. Most threat analysts I know today are working, either have worked or working on projects to implement this when they notice an external threat. Where does it map in Mitre ATT&CK, and where does that map to in my environment?
That's the story. I mean, that's the end-to-end story. The threat analyst models the emerging threat they're worried about in Mitre ATT&CK. Then he goes to the blue team and says, what controls do I have based on Mitre ATT&CK that this emergent threat is worried about? Hey, red team, go validate those controls are actually working.
Yeah.
And that's the
So it's a full cycle. Yeah. I think that's what we're coming to in a maturity level of Mitre ATT&CK, is using it for that full.
That's correct.
That full process.
And that's the key reason I came to AttackIQ, and that if there's anything I've observed in my 20-year career is that we have a major systems engineering problem in cybersecurity. If you were designing an aircraft engine, you would have a whole lot of information and telemetry about the individual components of that engine working and the performance of it within tolerance. We don't have that requirement in cybersecurity.
No,
today.
it's a great,
And so now there are, breach and attack simulation platforms that allow you to actually start building that continuous assessment of, does the current threat I'm worried about today, with an emulation, validate the control that I have is going to protect us.
I think it's less and less about missing patches. And sure, that's important.
Sure.
And way more about, what are my exposures?
Yeah.
And exposures were defined pre-Mitre ATT&CK by someone gave a presentation at a conference about this new advanced Windows exploitation technique.
Right.
Someone should have paid attention to that and take that back in.
Right.
Write some manual tests, maybe, right? Do some mitigations. But now it can be very much formalized. I think you can get a lot of momentum in your security program by using something like AttackIQ in conjunction with Mitre ATT&CK to do that continual testing.
Yeah, think about that point for a second. I was pulling off the GAO report on Equifax that was published last year, and that attack is often characterized as the struts vulnerability. You read that report, that the entire kill chain failed. Like
Yeah.
they didn't have
Yeah.
governance about sharing information. They didn't have architecture established right. A certificate expired, and they lost in decryption capability to actually interrogate traffic for 3 weeks. Like all of those things
A
were
lot of
part
it
of the
was
problem.
like what we have here is a failure to communicate. Right? A lot of it was communications just not being there, or if they
Yeah.
were communicated, no one was acting upon
There were
them.
governance problems, there were operational problems, there were incident response problems, and then there were PR problems. Like the whole thing, comes together that
Right.
way. And there's no silver bullet for all of those solutions. But if you have a continuous loop of always trying to iterate and clean up,
Yes,
it's
yes.
not annually based
Right.
and not a
right.
singular pen test.
I think that's one of the things that biggest mistakes we've made in security is doing that point in time vulnerability scan,
Totally.
audit, or pen test.
Totally.
Because it really is just a point
It gives false
in
comfort.
time.
It gives false
Right.
comfort that your program's working.
And if you're not testing the processes along with that, you're missing out. Like you said, in Equifax case, huge gaps.
Yeah.
They don't necessarily like, we didn't apply this patch.
Yeah.
It's like, well,
That's just the entry point.
exactly.
Yeah, all this other stuff failed too.
Mm-hmm.
So it's really interesting. It's it's an interesting time to be a security executive. If you're familiar with the Ponemon Institute, we commissioned a study with Larry to ask a bunch of senior executives with very significant budgets. I think the average was $18 million dollars in security budget and Fortune 500 financials and things like that. Scary. 53% of the respondents, which Larry estimates actually be high, said they have limited confidence in their security program. So what does that mean? What does that say about like that gap you just articulated?
Right.
Like there are problems all around. How do you start tackling this? And I think it starts first and foremost with adopting that system engineering discipline of establishing continuous security validation as part of your program.
Chris, how do we communicate Mitre attack and its benefits to senior management?
That's a difficult thing to do, I've found. One, because Mitre attack's new. Two, the board is familiar with receiving information about the security program that's largely framed around your common security control frameworks and things like that. The CIS 20. I was reviewing, I think his name is Brian Frick from BBVA. He's got a nice LinkedIn page about how he translates the control maturity assessment to his risk communication to the board. And it articulates, I saw movement because of how I subjectively assess the control maturity assessment. That's kind of scary. So I think one of the things we got to do, and the thing that we're working on within AttackIQ, is how do you conduct the mapping of your NIST 853s,
Right.
your ISO 27001 to Mitre attack, and then you can actually instrument and illuminate the performance of those control families by kind of in aggregate adding them up in terms of the performance of them. And so that's kind of a future generation of where we want the product to go. So when you're actually measuring and assessing based on Mitre attack the performance of your security controls through adversarial emulation, you can then roll that forward and tell a more coherent, simpler story. It says within this control family, endpoint controls, I'm grading it a 7 because I have a continuous set of tests. And if those tests slip and fall because of a new emergent threat or because of operational failure,
Right.
then it comes down.
So it's mapping it into frameworks that executives are already familiar with.
I think
and further integration.
I think so. I don't think you can train the board to understand Mitre attack. You gotta make it simple. You gotta make it punchy. You gotta make it effective to communicate. More importantly, you gotta make it as close to real time as possible because of the volatility of the environment that the board's responsible for securing.
Agreed. If folks want to learn more about AttackIQ or get a demo or a trial, I don't know if you have such a thing, but
Yeah.
how do they do that?
Yeah, just come to www.attackiq.com, and then you can just register your interest, and we'll reach out to you and work with you for a demonstration. We're also at Black Hat here in booth 2216, so if any of your listeners are on now, come on by and see us. We're here.
Awesome. Chris, thank you so much.
It was great. Thanks for the time.